Hello, the internet. Welcome to Open Source Directions brought to you by OpenTeams, the first business-to-business marketplace for open source support and services. Open Source Directions is the webinar that brings you all of the news about your favorite open source projects. My name is Henry Badgery, and I'm the growth marketer here at OpenTeams. I'll also be your host for this episode, and joining me as the co-host is...
Hi, I'm Madikan. I'm excited to be co-host for this episode. I'm a postdoc at the University of Illinois at Urbana-Champaign. I work on an open source project called the YT Project, and I'm based in Urbana, Illinois.
And Aditya?
Hi, I'm Aditya. I'm an open source developer based in Bangalore, and I'm really excited to be here in today's Open Source Directions webinar. And today I'm going to talk a little bit about my latest open source project called RecallGraph.
Awesome. Well, welcome and thank you very much for joining us. We're very, very excited for this episode. But before we get into the juicy details of RecallGraph, here are some of the recent pull requests, or one pull request that Aditya's been enjoying. So what was your recent pull request that you found particularly interesting, Aditya?
Well, it has to do with ArangoDB, which is what RecallGraph is based on top of. And it adds a new type of traversal. So far, ArangoDB supports breadth first and depth first traversals. New traversal that, and it has been shared in the chat, that allows for edge weights to count as the sorting order. So this really comes in handy for a lot of real life use cases. For example, you're planning a trip between multiple cities, and each trip has a cost associated with it, whether you travel by flight or by any other means. And there is a cost associated with it. And this weighted traversal will directly give you, your path sorted by ascending or descending order of the price or any other cost attribute that you may want. So I think it's a really useful and really, great pull request. I hope it gets merged soon.
Awesome. Well, thank you very much. Yeah, Brandon has just also shared that in the chat, so you can see it there. And I think Madikan and I have something a little bit different. We're going to go with the tweet of the week. So we're going to share our favorite tweets that we saw this week. And mine is a little bit of a self plug, but basically we've been filming a lot of educational video content at OpenTeams in the hope that we can share that and help educate people about open source, but also primarily companies so that we can work towards making open source sustainable and help open source thrive. So I just wanted to share that tweet with you. It's a video we made about a few reasons why companies should consider using open source. So I'd love to, if anyone could have a look at that. And we're very, very open to feedback as this is one of the first videos, but there will be a lot more to come. And now we have Madikan. Would you like to share your tweet of the week?
Yes, of course. So mine is maybe a little bit more of a joke than our two more professional announcements just before this. This particular tweet is a picture of a map, and it's supposed to be like a rail system of the world. And it's like, imagine what the world could be like if you had this rail system. But the map is cursed. Like, the more you look at it, the more is wrong with it. So it, creates sort of linear paths between cities, but the cities are not even like in order geographically. And so I have no idea how that would work. It leaves off like whole continents. And so I think it's hilarious. It's a good example of something that like could look good when you first look at it, but then, you're cursed. So I'm sorry I've cursed our entire listener base today.
Oh, well, I'm sure we can move on. 2020 couldn't get any worse anyway.
Now you're definitely jinxing us. You're making it way worse, Henry.
All right, awesome. Well, thank you very much for sharing that. So RecallGraph, we're now just going to give you a bit of context and information about the project, but RecallGraph is a versioning data store for time-variant graph data. It lets you time travel over historical versions of your graph and run point-in-time lookbacks, traversals, and shortest path queries. It has 225 stars on GitHub, and I think we're going to answer a few questions and just see if we can dig a little bit deeper into the project, just to give everyone listening a bit of context. So Aditya, did you want to share your screen for this part, or?
Maybe in a while. So just to start with, right? Yeah.
Okay.
So I'll just start with quickly. What led to me starting to getting the idea of working with RecallGraph. So it was just curiosity, I just had this itch that I wanted to scratch. I had this idea of I've worked with graph databases before, and I've studied to some depth the internals of certain version control systems, Git in particular. Git itself also internally uses a sort of tree structure to store its commits, and it occurred to me that it might just work out if I use the graph structure itself, the graph structure of the graph, to kind of act as a version control layer for the data that it stores. So the initial intent was never to let it stretch beyond more than 1 or 2 weeks as just a hobby project, a side project, before I moved on to something else. But as I dug deeper, that hey, and this is actually a really complex and very challenging problem to solve, which a few people have published papers on it. A few people have come out with sample or reference implementations, but there's still a lot to be done for to bring something like this into the mainstream. So as it turns out now, it's been 1.5 years since I've been working almost full time on this project, and there's still a lot to be done. So,
that's great to hear, and I think it's definitely something that's very, very exciting. So I can't wait to dig a little bit deeper into this project. So can you actually explain a little bit about the history of the name and the logo, please?
Well, to be honest, logo is not my design. I'm really bad at designing logos, and in fact, even coming up with good names for open source projects or anything else for that matter. So initially, the name for this project was named EV Store, which is a really unimaginative way of just referencing the fact that it is in a way an event store for graph. So yeah, it started out as EV Store. Over time, I kind of came up with a few use cases for the public sector, particularly in the legal or in the law enforcement, or with other public works departments, especially the police force here in India. And so I thought, okay, let's name it Civic Graph. But none of them were quite reflective of what this product is at its core. So then, thankfully, some of my friends, jumped into the rescue. We had a brainstorming session for almost half a day, and eventually we came up with this name, RecallGraph, which is sort of reflective of what this is. And the logo is also, all thanks to them.
Can you tell us if there's any alternative projects that exist out there?
Temporal databases in general, yes, there are several. In the relational space, any database that implements the SQL 2011 standard or higher. These include the latest versions of SAP HANA, Oracle, there's IBM's DB2, I believe, MariaDB, and a few others. In the NoSQL space, there are databases that support various models, and I'll just list them out in no particular order. So there is MarkLogix, there is SerixDB, there is Event Store. I think some of them are document databases, and some of them do support the graph database model as well. There's Datamic, which is kind of like a multi-model database. It supports, it's an implementation, a reference implementation of the data log query language. And particularly in the graph database space, I quite recently came to know that there are a few other mainstream, version control graph database implementations out there. To name a few, there are Crux, and of course there is RecallGraph. There may be a few more, but that market is saturated as the, let's say, for example, the relational database space. There are very
great.
players here. Yeah.
Awesome. And what technology is it built on?
RecallGraph, first and foremost, it is not a standalone piece of software. It actually runs as a microservice layer on top of the existing and very well-known and popular ArangoDB. So ArangoDB has its own framework for building microservices. It goes by the name of Fox. Basically, what it is nothing but a JavaScript V8 engine, the same as the one used in Node.js, as well as the JavaScript engine for running Chrome and all its derivatives. So Fox microservices are nothing but JavaScript service files that run on the ArangoDB database server itself. The only peculiarity here is that it is 100% synchronous JavaScript. So there is no accessible event loop that the developer can leverage.
Okay, cool, very neat. And yeah, I think this is the case with all open source technology, that we're all built on, the shoulders of giants.
We
of other
stand on the shoulders
projects,
of giants.
right?
Yeah.
Yes, exactly. And yeah, and that's what I kind of like, this dependency graph, that you can see that on GitHub too when we look through stuff. So you kind of alluded to this a little bit earlier, but who started it? Is it you, or was there other people involved in starting the project?
Well, it was my pet project to start with, and I had no idea that it would evolve into something this big. But quite, recently it has started gaining popularity, especially after I made a similar presentation in the ArangoDB Open Source Community Pioneers Forum as well. And it has started picking up some momentum, and now I think it is at a stage where it is mature enough for serious users to consider using it, integrating it into their existing enterprise tech stacks. And I hope that through this, and I've just recently started seriously promoting or marketing this project. I really had no idea it would grow this big. So I hope I can start growing a decent user base. Some of those users may actually convert into major contributors as well. So far, I have been kind of like the only developer on this project.
Okay, cool. So I think we sort of covered the question there of who maintains the project then, because it seems like it's you and you're alone at the moment doing that, which is incredible. You've done a fantastic job doing that all by yourself. But I guess that's the benefit of now gaining users and growing the project, is you'll get more contributors. They start to flood in. So could you actually tell us just a little bit about sort of, I guess, what are the communities, do the users and because you're not your own but like other contributors out there, have you had any interest from them, and what communities mainly do the users come from?
Well, I mean, I guess that the first cohort of users is going to be a subset of existing ArangoDB users themselves, because this project runs on top of ArangoDB, so it'll have to be a double sell for somebody who is not used to ArangoDB or not used to graph databases in general. So I think my first initial marketing efforts will be concentrated on getting some existing ArangoDB users who are already convinced about graph databases, or at least the fitment graph databases for their use case and ArangoDB, and get some of them to see the value of RecallGraph, particularly for those people who have a need for retaining as well as querying past versions of the data. So I think that's where I'm going to start.
Yeah, I think building up this user base is challenging for any new project, right? And building and fostering that community and that inclusive space. So related to that, do you have any DNI efforts that the project is working on to try to bring in contributors from lots of different backgrounds?
That's kind of something that's yet to be seen. So based on whatever limited promotional efforts I have put in, there are one or two serious enterprise users trying this out, working on integrating this into their stack. As far as incubation efforts are concerned, well, I think I need to show some demonstrable traction on this project before anybody would consider seriously incubating this. I need to get more users. I mean, getting GitHub stars is good, but it's just the first step to getting serious adoption, serious traction. I need to show a demonstrable and sizable user base. Maybe get more contributors on board, and then maybe incubation would be the next step.
Awesome. Okay, well, thank you very much for sharing that. It's great to know a little bit more about the project. And we're now actually going to shift into the project demo section. So you will all get to see some of the cool features of RecallGraph and how it works. So while Aditya is getting set up, we'd also like to take this opportunity to thank Quantside, our sponsor, for sponsoring this episode of Open Source Directions. So Quantside, creating value from data. So when you're ready, Aditya, take it away.
Yeah, just sharing my screen, and if you don't mind, I'll just switch off my video feed because limited bandwidth. I'm kind of like on ancient hardware. So, so are you able to see my screen here?
Yes. think I can.
I hope
Yep,
you
now
can
we
see my
can hear
screen
you.
here.
You just froze for a second.
Just let me know when you can. Okay. All right. So what you're looking at is the ArangoDB web console, and the reason why I've opened this up is there's nothing particularly out of the way as far as installing. Once you install RecallGraph into an ArangoDB database, there's nothing unusual. There's no voodoo magic going on. Here you see a bunch of collections, and there's there's some data inside these collections. So the demo that I'm going to run here is a very simple case of searching for flights between cities. So this database has a bunch of cities, and there's a bunch of flights. All the flights have gone through multiple changes, changes to their price, changes sometimes to their departure time. And what you're looking at right now is the latest version of the particular flight. But every individual flight entity has a history that has been stored somewhere in the background inside RecallGraph. So to start with, let me just run a query to find out which particular flight entity has gone through the maximum number of changes. This is once again done using one of RecallGraph's many, let's say, aggregation-based queries, which you can run on the event log. So we see that a particular flight going by the name 66401, blah, 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 has gone through 10 different mutations. So what I'm going to try next is to try and fetch its changelog. Now, the changelog basically is similar to Git log, wherein you fetch the last few changes that a particular subdirectory or a particular file has gone through. So what you see here is a bunch of sequentially ordered events, and I think these events would be ordered in ascending order of their time. So we start with the first event that signifies that the flight entity was created, followed by a bunch of update events. And since the total number of events was 10, I guess there would be 9 update events after the create event. Now, what I'm next going to do is I'm going to run this. I'm going to basically fetch successively older versions of this flight. And what I'll try is paste this data inside a diff tool so that we can see for ourselves what really is. And I've set up a few scripts and fire this query. It fires it. So the flight changes. So we just copy this and paste this here, and I'll do that. And hopefully we'll see something has changed, and some things have not. So, right. So what we have here is any line that is highlighted in red, basically signifies a change. And let's also note that the flight ID is exactly the same in all 3 different versions. So I'm not really looking at different flight IDs. It is the same document ID, but RecallGraph has managed to store all the historic revisions that this flight has gone through. Most interesting of which would be that the price has gone through several changes. So I believe the latest price entry is $107 US, and all prices here are marked in US dollars. The latest entry is $107 US, but it was priced at $213 at some point of time in the past, and before that, it was priced at $324. So this is just an example of how RecallGraph can store and retrieve historic versions of individual nodes. These nodes may be vertices or edges. So RecallGraph does not really distinguish between that. A second part of the demo would be, and I really don't want to spend too much time on this. I covered bits of this demo in one of my previous talks, and I'll share a link to that here. Let me just try and run an open-ended traversal and see if I can get some kind of a changes and changes. So let me see what I get here. Give it a few seconds to load the visualization. Okay, so here's a traversal that searches for outgoing flights from in the current database from Bangalore International Airport that are just out of. And let me just fire this at a different timestamp, and hopefully we'll see some changes. Something, I mean, yeah, okay. A bit of results. Yeah, so if you compare it, I mean, if you kind of, got a sense of how many outgoing flights were there in the previous query and how many outgoing flights you're seeing right now, the number of flights has changed. And if we take a look at any one of these individual flights, as I did just a while back in the demo, some or the other attribute would have changed there as well. So this is just a very simple and very short example of how RecallGraph supports point-in-time lookbacks, point-in-time traversals. There is also another part of the demo wherein I show point-in-time shortest path queries. So I'll just quickly go through it, not run the demo as such. We don't have time for that. So basically, you want to find the least expensive path between any 2 points, and depending on what point of time in the database you're looking at, you'll get a different result. So RecallGraph, really supports all of that, and I really encourage viewers who have joined in to take a look at the previous presentation I have made, wherein I've covered this demo a lot more thoroughly. So if you guys are okay, should I take some time to explain a little bit about temporality, the concepts of temporality as they apply to databases?
Okay, yeah,
do we have time for that? Okay.
Yeah.
So as far as file-based version control systems are concerned, we only track their revisions as soon as we commit a change to a file. That is the time at which we commit the change. That is the time from which that particular revision becomes effective. But in case of databases that store real-world business data, that one single commit time itself is not really sufficient. That particular commit time, when brought into the database concept, into the database context, is referred to as the transaction time. It's basically the time on the clock when the server actually records a change in an entity, whether that change is a creation or an update or a deletion. But there needs to be another time dimension, which is called valid time. And basically, we need a different time dimension because the time at change is recorded may not be equal to the time where that change was effective in the real world. So let's say, for example, you want to import data from some legacy database into a new database. So the time at which you're importing is actually in the future, and the effective time for the legacy data is obviously sometime in the past. It could also be the case that the effective time is sometime in the future. For example, you want to record a particular employee being promoted or getting a raise preemptively, but the effective date for that promotion or for raise may be a few weeks in the future, maybe even a few months. So in order for a database to fully capture the essence of both aspects of time, it uses two time dimensions. One is transaction time and one is valid time. So a database that implements both these dimensions is called bitemporal. So RecallGraph, as of right now, is not fully bitemporal. It supports the transaction time database, transaction time dimension fully, and I'm working on making it fully bitemporal. So that would help it address a lot more real-world use cases. But even as of right now, RecallGraph can work in so-called real-time systems, wherein the transaction time and valid time can be considered to be the same for all practical purposes. So a few things about RecallGraph. It's, as I said, it's a Fox microservice that runs inside ArangoDB's embedded V8 engine. And it supports point-in-time lookbacks, traversals, and shortest path queries. Point-in-time queries is just one class or one category of temporal queries, and there are a lot more that are particularly useful when you want to run analytics on your graph data. When you're analyzing changes over an evolving network, or changes to an evolving network over time, point-in-time queries are useful, but there are several other kinds of temporal queries, and which is something I'll get to next. So RecallGraph uses the JSON patch RFC 6902 specification for storing deltas between successive JSON representations of a particular object, and this makes it very efficient storage-wise because it does not store an entire copy of the object each time that object is mutated. There are periodic snapshots taken on the event log. So this helps with efficient state rebuilds because you don't have to run the entire event log from the beginning to rebuild the state of an object as of right now. So there are periodic snapshots taken, and you can take the nearest snapshot from the point of time that you're interested in. And you can rebuild the entity by running the event log forward as well as in reverse. And finally, a fairly relatively new feature that I've added to RecallGraph is that I've enabled distributed tracing support using the open tracing specification. So whenever you integrate RecallGraph into your application stack and your application stack uses open tracing, you can get really deep insights into the workings of RecallGraph as well. So a few more temporal query classes. I've already gone through what point in time is about. You basically show the state of an entity as of a particular point in time t. Then there are other classes, other temporal query classes. So one is a time interval, where you specify a time interval and you're interested in finding out all the objects which were alive throughout that particular time interval. There could also be there could also be the inverse or the converse of this, that you're given a bunch of objects and you want to find the first point in time where all these objects came alive, or the last, or you want to find the maximum possible interval during which all these objects had been alive. Mm-hmm. And specifically for graph traversals, there is something called a time respecting path. What this means is, and this is more to do with valid time than transaction time in the real world use cases. This is more to do with when you're traversing a graph, every time you cross an edge, the next edge should have a valid time that is greater than or equal to the validity end date of the previous edge. This might be made more clear through an example. Let's say you're planning your trip and there are connecting flights that you want to take. So obviously your second leg of the journey has to begin at a time after the first leg of the journey ends. Otherwise, you will miss your flight. You'll miss your second flight. So when you want to search, let's say, a flights database in a temporal context, you want to actually traverse a time-respecting path so that every successive edge becomes valid after the previous edge has lost its validity. And this is this is a temporal query that is very, very specific to graph traversals.
Can you also join these queries together? Like, can you use point in time with interval lookup or something like that?
Point in time with interval lookup. Well, you
or
can
like
sort of
any combination. Like I just kind of chose two, but can you like join some of these queries together to do something kind of complex, or is that like in the future or?
Well, I mean, let's take an example. You find a state of the subgraph at a particular point in time, and that's a point in time query. And let's say you next want to find out the maximum interval during which this subgraph was going through a steady phase, meaning that none of the entities that comprise this subgraph have gone through any mutations. So it is possible to combine these queries, but they may just as well be fired in sequence rather than having to combine them in a single query. They may be fired one after the other.
Okay. Thank you.
But yeah, I mean, I've just started exploring all temporal query classes, and depending on requirements, and these requirements particularly come from the analytics domain, not so much from the transactional or the enterprise domain. So any temporal class, any temporal query class that really serves a need for a large number of users, I definitely intend to implement that. These are just a few of them.
Cool. Awesome. Thank you for explaining that. It's really cool to be able to see these queries, and your example is a nice sort of context for them. So this is really nice.
Thanks.
Okay, great. Well, now we're going to move on to the roadmap discussion. It's another fun segment of this webinar where we're going to talk about RecallGraph and where it is heading and what kind of future direction it'll be taking. So with that, Aditya, can you please tell us a little bit more about the directions that RecallGraph is heading?
Right. So RecallGraph so far has been built along the lines of a version-controlled database. Basically, it's a version control system, but for data. But having come to the point where I am right now, I realize that there is a lot more potential for it to become a really powerful tool for dynamic network analysis, which is basically the analysis of evolving networks. So one of the big ticket items on RecallGraph is to make it fully bitemporal, basically add support for valid time. Following which, there will be a bunch of major and minor performance enhancements, basically make it work with ArangoDB clusters. The reason why I haven't supported ArangoDB clusters yet is that RecallGraph heavily relies on transactions inside ArangoDB, and ArangoDB itself hasn't yet come out with support for multi-collection asset transactions across clusters. So, as and when that comes up, RecallGraph will also fully start supporting clusters. Then there is also, of course, my idea is to keep RecallGraph at its core always fully synchronous and fully transactional. But I could add a smart proxy layer that acts as a layer on top of RecallGraph, wherein I could add a few more fancy features. I could add access control lists. I could add authentication and authorization. I could even add an asynchronous CQRS event sourcing operation mode, async bulk operations, and things that I really don't want to build directly into RecallGraph's core, but things that might, they might still be useful for end users. And of course, going forward, I want to add the most important temporal query classes that would cater to analytics use cases, because my vision for RecallGraph going forward is that it should not only be a useful tool, for, a version controlling data store for enterprise, transactional or, OLTP use cases, but also a useful temporal analytics tool. So whatever is required in order to get it there, including temporal query classes, or maybe add a complex event processing module, that's where I see RecallGraph heading.
So what are some of the temporal query classes that you would want to implement? Do you have any particular ones specifically that you are on your roadmap like first, or are you kind of exploring that still?
I am also exploring, trying to figure out, which particular temporal query class would be the most useful to start with, implement first. But I think there has been, to some extent, some interest shown in the time point lookup, wherein given a bunch of objects, you want to find a point in time, or maybe the maximum time interval during which all these objects were alive, or during which all these objects were in a state. So I think definitely time respect will come next. These are the ones that I think would cater to a large number of use cases.
Yeah, it totally makes sense to kind of focus towards a large number of use cases so you can build up your user base and then start kind of customizing some of your queries, or build out queries for maybe more niche use cases after that.
Could be, yeah. Could be. So, yeah.
Are there any particular features that you're like you have a very built out roadmap? It sounds like you've got a lot of really good things on the horizon. Are there particular features that you're the most excited about, or anything in particular that you that you're the most excited to start working on?
I would say that the very next feature that I want to build would be implementation of valid time. And I think it's going to be really challenging for me to get this thing working in a way that is easy to understand, easy to use, and also bring it up to par with the other version control graph database systems out there. So that's the first thing I want to do. So there are fully bitemporal graph databases out there, and that's the first thing I want RecallGraph milestone that I want RecallGraph to cross. And it's quite a challenge and quite exciting also. That's what I'm going to work on next.
So I had a question for you actually related to this bitemporal time thing. So can you do queries on both time variables, or can you only really work on one versus another?
Absolutely. You can work on, you can do queries on both time variables. So you can say, let's say, for example, what was the, what was the price of this particular product item as it was best known at a certain point of time in the past. So you can specify both the transaction time point as well as the validity time point. This could be useful in a case where, let's say, you have an e-commerce store and you have an upcoming flash sale. You want to basically mark down some of your on-sale product prices in advance, preemptively. So you mark them down today, but you don't want them to be effective from today. You want them to be effective from the date of the flash sale. And until the flash sale arrives, you might make a few changes to the product prices until you really finalize, come on to the final version of it. Let's say you make some changes today, you make some changes tomorrow, and then the day after tomorrow your sale begins. After the sale ends, you kind of want to figure out what was the effective date of this product price change as of 19th of June 2020. And then again, what was the effective date of the product price change? And this effective date is the valid date, and as of 20th of June, which is the transaction date. So yes, absolutely. To answer your question, you will have both time parameters, both time dimensional parameters when it comes to querying your data. The only limitation may be that when you're updating your data, I may put a restriction that you can only update the latest version of your data rather than having the ability to go back and change the past too much. It's difficult and confusing to comprehend as well for the end user. I mean, it's easy to get lost in two time dimensions. They may not really have such a requirement for such a complex and powerful feature. So I might keep things simple on that front.
I think that totally makes sense.
Yeah. But as far as querying is concerned, yes, absolutely. Both time dimensions will be supported.
Okay. Cool. Okay. Thank you.
Great. Yeah, it's great to hear where the project is heading. Very, very exciting. And I can't wait to see where it goes in the future. So now we're going to answer a few questions that we've got from the audience. Aditya, do you want to kick that off?
Yeah, sure. Let me get everything up. So can you tell us what are some of the interesting use cases that you've seen for RecallGraph? I know that you're a little bit in the beginning stages, but what are some of the interesting use cases that you know about?
Generally, to generally put it out there, any scenario where your data is highly interconnected, meaning that it can be represented as a network or as a graph, and also it is important for you to be able to store and retrieve historic versions of your data. So you're not just interested in your overall network state as of right now, not only the current state, but you're also interested in historic data states. So anywhere that you need version control over your highly interconnected data is a potential use case, is where RecallGraph could be a good fit. Just to put a few examples out there, anywhere that you need to maintain an audit trail, you could use it for building social networks. You could use it for building for master data management, for configuration management databases. For as I explained in my demo, you could build travel portal websites, e-commerce stores. But apart from these, very common enterprise use cases, you could also use it to maybe simulate something fancy like a railway signaling network and see how the efficiency of the track utilization changes as you change your signal timing arrays. So you could run a lot of interesting experiments that way. So that's more in the analysis domain. You could probably simulate nuclear chain reactions, and at each stage of the fission you get a new bunch of nuclides, and you want to store their relative concentrations as well as their relations to, the relations of every generation to its parent nuclei. So, in chemical as well as nuclear reactions, I think, a graph database might, I don't think it's been used this way before, but it just might come in handy.
Awesome. And just a question that I actually have is, have you considered using blockchain technology at all, or?
RecallGraph may be a good fit for blockchain, but to be honest, I really haven't studied blockchain in all that much detail to give a really well-informed answer to this. So just to be clear, is your question about have I considered using blockchain into building RecallGraph, or using RecallGraph for building blockchains? Is it
the former?
The former? Okay.
Blockchain, yes.
Well, no, because I think blockchains are meant to serve a different purpose. It's not really, and really, I don't come from a very informed perspective on blockchain, so I may be wrong about what I'm saying here. But really, to be able to query your data and to be able to, have a query parser, to be able to write your queries, to be able to run traversals, shortest path queries, the typical things that you do on a graph. I'm not sure if anybody has ever tried building a graph query engine on top of a blockchain. I'm not aware of such a thing, if it has been done, or even if it is doable. So blockchain is kind of like an immutable record that is kept over a distributed ledger. This is probably something different, because you have a lot of data that you want to very efficiently and very rapidly be able to query.
Okay, cool.
Yeah. Well, there are some similarities. I get where your question comes from.
How can people start contributing? I mean, right now you're basically the only maintainer and developer, but let's say somebody wants to get involved in the project. What sort of things do you need help with? And what would be good ways to get started working on the project?
I would welcome contributions in any form whatsoever, but I also realize that to jump directly into RecallGraph's core code and understand it and start making modifications to it may be a bit of a stretch. But there are a lot of other ways. There are some side projects that are built to support RecallGraph. For example, the distributed tracing that I mentioned. I have built, a module on the side that also runs on AraggoDB that helps collect the tracing data and push it to, different things. Right now, I have support for Datadog, and you can build out open tracing compatible things of any kind. So people can start contributing on those projects. The code base is much simpler, and open tracing is, it's not as a version control graph data store. It's fairly common. It's fairly well known out there. People could help me out with testing. People could help me out with getting better coverage, better code quality. People could help with the documentation. If somebody comes in and volunteers, suggest corrections or improvements to documentation websites, they're more than welcome. So there's a lot of ways in which people, and I think at this point of time, the biggest contribution that you can, the biggest way in which you can contribute to RecallGraph is to actually just start using it. And give me your feedback, right? Your feedback is one of the most important contributions I can get right now. Which to some extent, some people have already started doing, and I've started making, a lot of fixes, a lot of improvements, and I've started understanding really what do users prioritize the most. So I think, even if you just give me feedback on, what you want, I'll take that as a useful and welcome contribution.
Awesome. Well, yeah, thank you very much for answering those questions. They were very, very helpful and useful. And now it is time for our famous rant and rave section, where we each get a 15-second soapbox to basically rant or rave about whatever topic. So Aditya, it's your soapbox. You're up first.
Well, I have a rant here, and that rant goes by the name of the year 2020. I believe I could stop right here, but personally, been a bit of a tough for me because I had to be away from my wife and kid for over almost like 5 months because they kind of
Oh no.
Yeah, so they just before the whole pandemic and the lockdown started, they had left for my in-laws' place to spend maybe a week or two. And that stretched out into a period of over 5 months. And it is only now that, the lockdown has eased up a bit. And and it's not all rant for me. The good thing is, we're all safe, we're all healthy, and people are starting to figure out ways with the pandemic, and hopefully, I think there's a vaccine that's in its third stage of clinical trials going on. So we may see a working vaccine, by the end of this year. So there's a light at the end of this tunnel also.
Madikin, you're up.
Okay, so mine is, I guess, a nice building off of your rant. So mine is a rant, and I have a neighborhood email list. So, people say, here's some free stuff that I'm getting rid of. You can come get it at my front door. But since the pandemic started, everybody in my neighborhood has, I think, maybe gotten bored, and so are really enjoying starting arguments on the neighborhood email list. And so it's turned into a giant dumpster fire. So now I don't use my neighborhood email list as much as I used to. So.
Block it.
Yeah, it's extremely tempting. There's definitely some people. So I live in an academic town, and so there's some people who maybe are emeritus professors that have way too much time on their hands and also enjoy arguing. And so I'm learning that some people are, trained to be trolls, maybe. And, it's excellent or terrible. It's actually terrible.
Awesome. Well, mine's a little bit of a rave. It's kind of a weird one this week, but I thought just lately I've been thinking, obviously we're in a very tough time, coronavirus, but also a lot of other things that are happening. And I really have such faith in humanity to be able to bring about change and positivity. And I sort of wanted to share how excited I was about the future, because I think that while things seem now that it couldn't get worse, I really do believe that we are so strong and we are more connected than we've ever been. And I think that is going to put us in the best position than probably we could have ever been historically, to come together and fight everything and make sure we get through this time. So I thought that was something I wanted to share.
That's such a positive way to end our rant rave section, Henry. Thank you.
Usually it's about coronavirus, but I sort of steered clear of that. But that's all we have time for today. Thank you, everyone, for listening and for watching. You can find us on Twitter at OpenTeams Inc. and at Quansight AI. Aditya, where can people find you?
So I put in some links at the end of my slides, and I hope once this webinar is over, my slides will be shared along with the recording. But in general, people can find links to reach out to me on the project website, which is github.com/RecallGraph/RecallGraph. They can also reach out to me directly through email. That's webmaster@adityamukhopadhyay.com. Or they can even reach out to recallgraph@gmail.com. So, and there are a lot of other ways to reach out. They're all listed in the slides.
Thanks very much for that. And if you liked what you saw today, then please do go to our YouTube channel and like and subscribe to see more content like this. We look forward to also you joining us for the next episode. So please join us for the next episode for a juicy discussion on Julia.